Okay guys, so for some people who are having little difficulties maybe on the homework, let me just get so like on the homework, okay, this is the back side of it, front side, bam, there you go. To classify measurements as vector or scalar, you're basically just going to tell me, is it a vector quantity or a scalar quantity? If it just has a unit with it, it's a scalar. All right. It needs a direction and a unit to be a vector. Now, just FYI, negatives can count as a direction. Okay, if you think about it as a coordinate plane type of a thing, all right. If this was the x-plane, this would be like negative x, and this would be your positive x. Okay. And then you have your positive y and your negative y. So like a negative could mean like a left or a down or a backward kind of a deal. So this dude here would be a vector. All right. This is S, it's not capitalized, and it doesn't have south fully written out, so that would not be a direction. That is going to stand for seconds. When you get, let me just show this as part of like notes here. Scalar quantities have a magnitude or a number and a unit that goes along with it. Speed, time, distance, area, those are all different examples. Vectors require a magnitude, unit, and direction. All right. Oh, here's a little trick to maybe try and memorize them for like a quiz or a test. Scalar sounds like an STD. All right. It's a little acronym to help maybe remember. Oh, speed, time, distance. Vectors are my quote-unquote fave, which is going to basically stand for force, acceleration, velocity. So these dudes get a magnitude, a unit, and a direction. All right. A lot of the times you'll have like positive and negative. All right, for these dudes, velocity is basically speed with the direction. So you're moving, you know, how many meters per second east or west, left, right, up, down, any of those guys. Now, in the diagrams, we're representing vectors with arrows. Okay, so if their arrows are in the same direction, you add them. So I showed here as an example, 3 and 5 both going up. Okay, if they're the same direction, you add them. So 3 plus 5 is 8. Same direction is still going up. If you have something that comes across in the opposite direction, you subtract them. All right, larger number minus the smaller, and then the direction that will go would be in the direction of the original, like larger number. So 7 minus 4 is 3. How do I know what direction it's going? Well, this arrow 7. All right, that's larger than this guy, so it would be going in that direction. Now, what happens when you have more than one? All right, basically when you have a net x and y direction. So if you simplified everything basically with your same directions going add them, opposite directions you subtract, and you wind up with more than one resultant. That can't happen. A resultant is one dude. So let's say you had 7 meters to the right, 8 meters north. You can't add those or subtract them. You have to use this equation. It doesn't matter who is A or who is B in the equation. All right, the resultant vector here from this starting position to the final position, all right, is basically letter C. This is the equation that we know. So I'm just going to put 7 squared plus 8 squared. You type that into a calculator. Okay, you come out with 113. Let me zoom out and just show it real quick. All right, so 7 squared plus 8 squared, bam, 113. Some people have left that as an answer. That's not the answer. If you look in the equation, you have to square root what's under there. We just did what was under there. We didn't square root it. So now we got to square root that 113. Okay, and I get 10.63. That is going to be how you would do one of those problems on the homework. Now you have to, I would always give 2 decimals All right, always give 2 decimals at least. You can do more, but always 2. All right, so that's the magnitude. The unit is meters because these were in meters here. And the direction, well, if this way is going east and this way is going north, okay, you could say northeast or show me the direction that it would kind of go. It doesn't have to be 100% accurate, but yeah. So just as a quick, well, wait, you showed us ones with just 1 or 2 arrows. What about what's going on here? Easiest way for me to do these guys would be if you have them in the same direction, first simplify those. So 6 and 4 are the same direction. So if I added them, that would give me a 10 meters to the right. And nothing else except a 3 to the left. Okay, 10 minus 3 is 7 meters. Which arrow direction was bigger? 10, so the 7's going to go to the right. Okay, that's how you would do a problem like that. On the back side, all right, you already have this. You're going to use the equation. You have this dude. You're going to use the C equation. Okay, the C is equal to a squared plus b squared square root. Now this one is a combination because you have to subtract it and or add things. Alright, so my suggestion would be to simplify always if you can. Anything going in the same direction, you should say 6 and 2. So we're going to add them together. 6 and 2 is 8. They're going in the same direction, so we have 8 going to the right. Okay, now I got 4 up. Nothing else is going up, so I can't add it, but I have something going down. Opposites, we subtract. So 4 up and 2 down, when I subtract them, okay, that's going to give me 2, but in what direction? Well, 4 is going up, and it's a larger number than this guy, so it's going to be going up. Okay, well, I can't add these or subtract them because they're not in the same direction. They're not opposite directions. So you plug them into your equation. So if I just kind of redrew this as 8 meters this direction, 2 meters this direction, 2 squared plus 8 squared, square root it will give me the answer that I need. Okay, throw it into the calculator. It's 4 plus squared, 68, square root that number. Okay, and I would get an 8.246. So I would round that to me. You could write it as 8.246 or 8.25. That's not, you can't leave the answer like that because it needs a unit. All right, the unit happens to be still meters. And the direction, well, we went east and north again, so northeast. Okay, once you get it, box your answer. So that, guys, should take care of that homework. That should explain how to finish everything else on the homework. But as far as the other assignments, okay, you should have watched the video in class or online already. That should help you answer these guys here. Someone was not sure when they answered this. They're just like, oh, it's going to make an L shape. It's going to go down to the right or up left. Well, vectors can be added, all right, together from tip to tail. But this would be our original starting position. So if you started here, went kind of this way and then straight to the right, you ended here. So the resultant vector is going to be this line. That's your resultant vector. Okay, so in some way, if you don't know how to do the drawing, I think I showed it in one of my classes or two. If I didn't, you can basically just explain that it's going from the start of the bottom left guy to the top of the arrow of the right guy over here, the right vector. Then that's going to be your result. Here, again, using the equation, all right, answer these and then give 3 examples. All right.